Hello, ladies and gentlemen. Way back in 2014, I played a game called Antichamber, which has a room featuring some really cool visual effects. Each one of these boxes has 4 overlapping art pieces, but you can only see one at a time through a given window. It creates this effect where it seems like each side of the box has a window into a different dimension. If you're anything like me, you probably spent some time wondering how the developer achieved the effect, and if it was possible to replicate it in another engine. Luckily, it's fairly easy to set up the effect using just Blender and Unity, and I promise that by the end of this video, you'll not only understand how it works, but you'll also have your very own version to play around with. Before we get started, I want to talk a bit about why I'm creating this tutorial and what my plans are for this channel. I very recently decided that I want to enter into the world of solo games development, and I was a bit surprised by how sparse the tutorial landscape is for total beginners, especially those without much programming knowledge. Don't get me wrong, there are a lot of great channels out there, but I still often feel like I have to gather bits of knowledge from all over the place in order to put something together. With this channel, my goal is to provide completely self-contained tutorials, from which you can hopefully walk away feeling confident in your knowledge of that video's topic. With that in mind, I've made the decision to avoid using shader graph, which is a useful tool but can often obscure what is actually going on under the hood. I'll also provide a link to my GitHub for anything I make in Blender, just in case there are those who aren't familiar with it and would rather get by without it. I'll also provide links for the final code for those who want the effect but don't want to deal with the programming. I've set this video up so that each section will be self-contained, so feel free to skip over whatever chapters you don't feel like listening to. And finally, I want to give a shout out to Daniel Illett, who does a good job breaking down how this effect works. He's got a great channel and he definitely deserves your subscription. If you want to learn more about how shaders work in Unity, you should also check out Benjamin Swee's channel. He can teach you a lot about how to create your own shaders, and in my opinion, his channel is really underrated. To understand how the effect works, you need to understand a bit about what a shader is and how they work. If you've ever created a material in Unity and changed its color or smoothness value, then you've interacted with a shader. In Unity, shaders are what give our objects their color and transparency, and also allow them to interact with light and shadows. In order to render objects to our screens, Unity passes information about the object, such as its position, how many faces it has, and how many vertices it has, to that object shader, along with any image textures that we provide. The shader then takes all that information and runs a bunch of calculations inside your graphics processor in order to determine exactly how every single pixel on that object should look. This is done for every single object in your scene, and the final image is sent to your screen to be displayed. If you want to make any changes to how shader renders its object, we can actually go inside that shader's code and make any changes we want. For example, here is the shader code for this object. If I want to make every pixel in this object half as bright, I can actually go to this line here, where the color is returned, and then divide the value by 2. Now the color value for every pixel is half of what it was. Later in the video, we'll talk more about how to access the shader code and apply it to an object. Next, in order to create the effect, we're going to use something I'm calling stencil buffer filtering. The stencil buffer is a 2-dimensional array of numbers equal to the size of the screen, with a number corresponding to each pixel. Here's an example of a stencil buffer with all zeros, which I believe is the default value. Typically, it's used by 3D game engines for shadows and reflections, but we're going to use it to disappear and reappear objects at the right moment. And luckily for us, Unity gives us a way to access the values in the stencil buffer through the shaders of our objects. To make things easier, let's imagine we have a game which is rendered at a resolution of 10 pixels by 10 pixels, and then sent to our screen to be displayed. The stencil buffer for the game might look something like this. One of the applications of the stencil buffer is choosing which pixels you want to display and throwing away the ones you don't want. So in my 10 by 10 pixels game, let's say I want to put the outline of a heart over the camera and only show the pixels inside the heart, throwing out the rest. What I can do is put what we call a mask inside our stencil buffer that looks like this. So now our stencil buffer holds the value 1 at certain locations. Then, during the rendering phase, for every pixel on every object, we can check if the value in the stencil buffer at that pixel is 0 or 1. If the value in the buffer is 0, we can keep that pixel. If it's 1, we don't render that pixel and just return black. Instead of passing in a mask for the camera, you can also change the values in the stencil buffer on the fly while rendering objects, which is what we'll do in order to actually create our effect. Let's take a look at a simpler example of the Antichamber box, also using the stencil buffer. Here, this monkey scene is only rendered when it's inside the picture frame, creating a portal-like effect. Let's break down what's going on here. For every frame, as in frames per second of the game, the picture frame is the first object to be rendered. I've added a bit of code to the shader of the picture frame which tells it to put a 1 inside the stencil buffer at every pixel. And I've also coded the picture frame to be completely transparent in the middle. Remember, we're talking about thousands of pixels here, so the ones that I've added to this picture frame definitely aren't to scale. It's also important to remember here that the rest of the stencil buffer, which covers the rest of the pixels on the screen, still contains all zeros. So essentially, when the picture frame is rendered, the shader's only job is to put a bunch of 1s in the stencil buffer at that position. After the picture frame is finished rendering, the monkey is rendered. I've added a bit of code to the shaders of the monkey and the red background which says, only draw the pixels on this object if the value in the stencil buffer is 1. And since the picture frame has already been rendered, the only places where the stencil buffer is 1 are the pixels inside the frame. This means that only the pixels which overlap with the picture frame's pixels are drawn, while the pixels outside of the frame are not drawn. You can see by the outline in the Unity editor that the rest of the monkey is still here. It's just not being drawn to the screen. This is the basis for creating the Antichamber box, but instead of one picture frame putting the value of 1 into the stencil buffer, we'll have 4 different picture frames each putting a different number into the buffer. We can then create 4 different objects and tell each object to render only if the correct number is in the buffer. Okay, so before we get started in Unity, we're going to need to actually make the props that we're going to use. So I'm going to go ahead and use Blender here, and if you've never used Blender before, this might be a little quick for you, so I would recommend looking at some tutorials on YouTube. There's a lot of good stuff. Just to learn the basic hotkeys and how to move stuff around. So with that, let's get started. So I'm going to make a new general file, and we can go ahead and delete the camera and delete the light source. And let's delete the default cube as well, and then add another one. Add mesh cube, and then we're going to make this one 1 meter size. Okay, so let's go ahead and grab him, look down the Z-axis, G to grab, and then move him here with control. Okay, and actually let me go ahead and turn on screencast. There we go. Okay, so let's look down the X-axis now, grab him again, and we're gonna move him right here. Okay, and then into edit mode with tab, face select, grab the top face, look down the X-axis again and press G to grab, and we're going to move down to, let's say, right here, okay? And then what we're going to do is make some loop cuts to change the shape. So look down the Z-axis, Control R, move your mouse up to the top to make this vertical loop cut, left click, hold Control, and then drag it to right here, okay? And then hold press Control R again to make another loop cut. This one's going to be horizontal. Left click, hold Control, drag him down here. Okay, so we should have something looking like this now. And then what we're going to do is go to face select. We're going to grab this face, hold Shift, this face, and this face. And then look down the X-axis again, press E to extrude, and we're going to move these up just 1 block by holding Control. Okay, so now you should have something looking like this. So this is going to be the basic corner of the frame of our box. So then what we can do is grab just this face, look down X-axis again, E to extrude again, hold Control, and then move him up to the XY plane. All right, so there we go. That is 1 corner of the Antichamber box. Now what we're going to do is use a mirror modifier. And what this is going to do is reflect the corner across all 8, I don't know, I guess corners of the grid, and then that's going to connect the box. So what we need to do first is, while in object mode, hit Control A, and then apply location. And the reason we do that is because the mirrors reflect across the object's origin, so the origin needs to be in the center of the world. So now go down here to the modifier tab, add modifier, and we're going to add the mirror modifier. And then by default, it's across the x-axis, so we're going to do the y-axis too, and then the z-axis. And that's exactly what we want, so we're going to go ahead and apply the mirror modifier. And there we go. So this is going to be the frame, and we also need some windows, and those are actually what we're going to be putting the stencil buffer shaders on. So let's stay in object mode, and then what we're going to do is add mesh and plane. Okay, and then this is actually a good point to bring up back face culling in Blender. So right now this plane has 2 sides, but when we import it to Unity, only one of these sides is actually going to render. So to make sure that we have consistency between Blender and Unity, what I'm going to do is go here and then do back face culling. So now this is the actual side of the plane, and this is what you would see in Unity if you looked at the other side, okay? So we're going to grab him, look down the y-axis, press R to rotate, hold Control, and then we're just going to rotate it 90 degrees, like that. Press G to grab, hold Control, move him here, left click, and then let's resize it so it's the same size as the window. So look down the x-axis, press S, hold Control, and scale him down like that. Okay, so that is exactly what we want. Now what we're going to do is actually, what we're going to do is click him, Control A, apply location, and apply rotation. And what we're going to do is use Shift D to duplicate, so now we have another one, and then right click to just put it right back where we found it. And then we're going to hit R to rotate, and then Z to rotate around the Z axis, okay? And then hold Control, and then just move him all the way around here like that, and then left click, and it should be negative 90 degrees. And the reason we applied the rotation and location to the first plane is because we wanted to rotate this guy around the center of the world. So it's almost the same reason we applied before we used the mirror modifier. Okay, so this is looking pretty good, but now we just need to add these window panes to the other side. So let's click him, go to the modifier tab again, add modifier, and again, make sure you're in object mode to do this. And then add the mirror modifier. And then let's see, that is actually already what we want, so we can go ahead and apply this one. Okay, and then let's do the same thing for this guy. So add modifier, mirror, and that is also correct. That's weird. Yeah, I thought I have to do the y-axis here, but I guess not. Anyway, so yeah, x-axis, and that's perfect. That's all 4. So then apply. Okay, and then now what we're going to do is, so each of these windows is going to need a different material. And we're going to need a material for this frame, but I want all of these to be on the same object, just so that's easier when we import it to Unity. So what I'm going to do is hit A to select every object. You could also select them up here. And then what I'm going to do is object and join. So now these are all the exact same object. But if we applied a material to this, it would apply to every single face on this object. So all these windows would have the same material, and this frame would have the same material. So what we're going to do is go into edit mode, and then this is the material tab. So these materials are basically the same thing as in Unity. You can kind of customize them as you like. So what I'm going to do is hit A again to select every face, add a new material, and we'll just call this guy frame, like that. And then we can leave the base color as white, and then let's hit assign. So this is going to be assigned to every face. And then what we can do is then assign each window a different material manually. So first, I'm going to click this guy, use the plus to create a new material, hit new, and then we'll call this window 1. And then I'm going to hit assign, and then let's make this one red just to differentiate it. And you don't see anything here, but that's because we're in the, what is this? Viewport shading. So then what we want to do is go to material preview. Sorry, this one is solid. This is material preview. So let's hit this one. And then now we see the frame and the windows are all the same color except for this one, which is red. So that's how we know this is a different material. So let's go ahead and do that again for this window. And you could probably guess what's going to happen here. So if you want to just skip ahead, that's fine. But feel free to follow along. So this one I'm just going to make green. And that didn't work because I didn't hit assign. Make sure you hit assign while hovering over window 2. And now it's green. And then same thing for this one. So new material, new, window 3. And let's make this one blue. And then remember to hit assign. Now it's blue. And I guess we could just make this one yellow. So one more, new, window 4, like that. And then let's select yellow and assign. And there we go. So now every single face of this box has a material. The frame has one, and each window has one as well. So in Unity, when you go ahead and drag and drop a material, you have to carefully select which face you drag it onto, and then it'll be assigned to that face. Okay, so let's go ahead and save this. Always remember to save your files. I'll just leave this as untitled. And then what we can do now is let's actually hide this and begin to work on something else. All right, so now that we've finished the frame, what we're going to do is make what are essentially the walls on the inside of the Antichamber box. These are going to get the same material as whatever object is inside the box, and it's akin to that red background that I used for that monkey portal shader earlier in the video. So to make that, what we're going to do is go back to viewport shading and then make sure you're in object mode. And then we're going to add mesh cube. And then we need to figure out the correct size for this cube. So let's go ahead and unhide the frame by clicking this eye icon right here. And then look down the y-axis, press S to scale, hold Control, and then scale him to right there. Okay, so you can tell that's the right size because it's fighting with the windows right now for which should be viewed. And then we can go ahead and get rid of that by hiding the frame again. Okay, so now we have a problem because if we just left this as is, when we render the inside of the box, what we just see is a flat face right here. We wouldn't see anything behind it. And the other problem is if I go into edit mode, face select, and then select just the front face, and then press H to hide it, this is what we would see when we looked inside the box. Essentially nothing, because Unity and Blender are going to not render the other side of these planes. So I'm going to press Alt-H to unhide that. And then while in edit mode, I'm going to press A. That's going to select every face. And then I'm going to go to Mesh, Normals, and then Flip. So what this does is tell Blender and Unity that we actually want to render the other side of all these faces. So now the outside is what we don't see, and the inside is what we do see. So if you imagine that we're looking inside the box, we see a wall on every single side, and that's no matter what face we're looking into. So this is kind of a neat trick you can use to create a sort of an optical illusion on a bunch of different objects in Unity. And that is actually it for the box. I don't think we need to do anything else for this though. Let's go ahead and Control S to save, and then we can unhide the plane here too. Okay, so now we're going to export these objects to Unity, but we have one more step. So with the cube selected, that's the inside box, I'm going to press Control A and apply location, Control A rotation, Control A scale, and then I'm going to do the same thing for the frame. So location, rotation, and scale, and that's just to make sure that the scale is correct when we export to Unity. So if you haven't already, go ahead and create a new empty 3D project in Unity, and make sure you know where the folder for that project is located because that's where we're going to be exporting. So with the frame selected, I can go to File. Also make sure you're in object mode, by the way. Go to File, Export, FBX, and then go to wherever your Unity folder is located, and then go inside the assets. This is what my assets folder looks like. And then you can go ahead and create a name. I'll just call it frame. And then we'll limit to selected objects and apply transform, and then export. And then let's go to the cube and do the same thing. So File, Export, FBX. We'll just call this box. Limit to selected objects, apply transform, and export FBX. So we should be good to go. I'm going to save one last time. And then you can feel free to exit out of Blender now. I'll see you back in Unity. All right, so here we are in the Unity editor. And you can see that we have our box and our frame right here from Blender. And I've gone ahead and created a plane as the floor. And then I created a new material to apply to the floor. And we can go ahead and toggle off these gizmos with this button up here. And let's go ahead and drag our objects onto the scene. So here's the frame. And let's put it at 0, 1, 0. And then I'm going to drag out 4 instances of this box. 2, 3, 4. Okay, so what we need to do first is create the shaders that we're going to put on these windows, which are going to turn them transparent and are going to allow them to put values in the stencil buffer. So to do that, what we can do is create a new unlit shader by going here. And unlit shaders are just shaders that don't interact with light and shadows. And we can go ahead and call it window 1. And at this point, you need to have a code editor installed on your machine. If you don't already, I would recommend you download VS Code. And then what you can do is go to Edit, and then Preferences, go to External Tools, and then right here where it says External Script Editor, just set it to Visual Studio Code. And then that should allow you to double click on the file to bring up the shader code. And if you've never seen shader code before, this is going to look insane, but I promise it's a lot less scary than it actually is. And we're not going to use most of what's here anyway. And if you don't have these different colors for the different data types, what you can do is go to Extensions, install the C++ extension verified by Microsoft, and then that should allow you to have your code look a lot better. Back in our scene, what we can do now is right-click the shader file we just created, Create Material. And what this is going to do is create a material based on this shader file. So whatever we put this on is going to receive the code from this file. So if we go ahead and put this on our window, you can see it turns bright white, and then it does not interact with shadows anymore. And that's because this is an unlit shader. So if we go back to the code, what we want to do first is turn this window transparent. So we can go here to Render Type, and then just change that from opaque to transparent. Control S to save, back to the editor, and nothing happens. Why is that? Well, this is actually just a tag that tells Unity how to organize this shader. What we really want to do is assign this to a render queue that tells it to render this after all of the opaque objects so that we can still see them. So if I do Q is equal to transparent like this, Control S, back to the scene, and nothing happens. Okay, so I lied. This is a necessary step, but it's not all we need in order to turn that transparent. What we want to do is go down here to where the color is returned. So this is returning an alpha value of 1. And the alpha value is what tells Unity how opaque or how transparent the object is. So if the alpha value is 1, the object is completely opaque. And if the alpha value is 0, the object is completely transparent. So what we can do is return fixed 4. This is something known as typecasting, and the reason we're doing this is because you need to return a fixed 4 at the end of the shader file. So we're going to do return fixed 4, and then we're going to keep whatever RGB values are in our color, and ultimately those aren't going to matter. And then the last value here is going to be the alpha value. So right now, this is returning call.a, which is the alpha value from call here. But what we're going to do is set this to 0. So we're going to say that the alpha in this object is completely transparent. So if we go back to Unity, nothing happens still. So why is that? Well, this part is a bit weird, but you actually need to tell the shader what to do with the alpha value. It doesn't know on its own. So we're going to write some really weird code right here that says blend source alpha 1 minus source alpha. And this is extremely strange, but you can try to read it as a sentence. So this sentence says, I want to blend this object with the objects behind it, and the contribution of this object to the blending is its source alpha, which is 0, so in other words, no contribution from this object. And the contribution of the objects behind it is 1 minus source alpha, which in this case is 1. So in other words, the contribution of the objects behind this object is 1. So this object, completely transparent, objects behind it, completely opaque. Hopefully that makes sense. So now if we save it and go back to Unity, finally it's transparent. All right, so there's one more thing we need to do for transparency, and that is to add this line right here that says zwriteOff. And that is telling Unity that we do not want to write this object to the Z buffer, also known as the depth buffer. And the depth buffer is pretty similar to the stencil buffer in that it's an array of numbers with a number for each pixel on the screen. The idea is that when we're rendering objects, we want to figure out which ones are in front of others to decide that we don't want to render objects which are blocked by something else. So let's imagine a scene here with no objects, and the camera is pointing in a certain direction to the right, and since there's nothing in front of the camera, the depth buffer is empty right now. And so now let's say there's an object at a distance of 1 meter, and it's in front of the camera. So what's going to happen is, for every pixel on that object, the corresponding depth buffer number is going to be updated to 1. So now when we have another object, which is, let's say, directly behind that first object at a larger distance, what's going to happen is when Unity starts to render it, it's going to look inside the depth buffer, and it's going to ask a question, and that question is the distance of this object greater than what's currently in the depth buffer? If it is, then we don't want to render this object because it's directly behind something else, so it's being blocked. So we don't want to waste time rendering this object. If we think of our example where we turn zwrite off, then even though our object is in front of the camera and it's at a distance, it's not going to update the depth buffer. So when we add another object that's directly behind this one, even if it's at a greater distance, there was nothing in the depth buffer. So Unity is going to update the depth buffer with this distance, and it's going to render the object. So you can imagine that this would be pretty weird if you had an opaque object with zwrite off, because then you'd have some unexpected results with two objects which are sort of overlapping. But if you have a transparent object, like let's say a window, then you want to turn zwrite off because you want to see the objects that are behind the window. So that's a lot to remember, and you're going to have to do that every time you write shader code for a transparent object. But I hope it helps you understand what exactly is going on when you turn an object transparent in Unity. I myself didn't realize there were so many steps, but now that I understand all these steps, I understand a little more how transparency works in graphics engines. All right, so we're finished with transparency. Let's get to the stencil buffer. So back in our code, Unity makes it pretty easy to access the stencil buffer in code. All we're going to do is write stencil and then add a set of curly braces, which are going to contain our code. So the first line we're going to write is ref1. And this line says create a variable named ref and then put the value 1 inside that variable. Next, we're going to write a line that says comp always. So this line is part of what's called the stencil test. And if you think about it as a sentence, it basically says, don't worry about whatever's in the stencil buffer at this pixel. we're always going to pass this shader. And the final line is pass replace. So this says once the shader passes the stencil test, then replace whatever's in the stencil buffer at this pixel with the value in ref. So the value in ref is 1. So at every pixel on this object, we're going to replace the value in the stencil buffer with the value 1. So go ahead and Control S to save, and then back to the Unity editor. You shouldn't see any change because there's no other objects in our scene that interact with the stencil buffer. Okay, so that is it for the window. Now what we need to do is create the shader that we're going to apply to objects that are inside the Antichamber box. So to do that, let's go ahead and right-click our assets, and then create, and then shader. And this one is going to be a standard surface shader because we want it to interact with light and to have shadows. So go ahead and call it inside 1. And we're going to right-click and create and material. So just like before, this material is going to apply whatever code we write to whatever object we apply this material to. So if we grab it and then apply it to this box over here, then nothing should happen because it was already using the standard surface shader. So what we can do now is grab this box and put it at 0, 1, 0. So again, make sure that this box has this material applied to it. So now let's go inside our inside 1 code. Okay, and this is what a surface shader looks like. It's pretty similar to an unlit shader, but it has some extra functions that deal with albedo, which is texture, metallic, and smoothness, which is like how shiny it is. But we're going to ignore pretty much all of this, and we're going to go right here and then add another line for the stencil buffer. So stencil, curly braces, and then what we're going to do is create another ref. We're going to pass the value 1 because this is for window 1. And then what we're going to do is say comp and equal. So if you remember for the last one we said always, which means always pass the stencil buffer test. This one says equal, so it's only going to pass the stencil buffer test if the value in the stencil buffer is equal to ref, and that value is 1. So basically, this shader is only going to render when it's behind the window we just created. So let's go ahead and Control S to save, and then go back to Unity, and we don't see the object. So what's the deal with that? Because we just said as long as it has the value 1, we should be able to see it. Well, the problem with that is that Unity is actually rendering the box inside before it renders the window. So in other words, it's rendering the box before the value in the stencil buffer is 1, because the stencil buffer is going to reset every time we have a new round of rendering. So what we need to do is go in here, and then we're going to create another Q tag like we did before. And make sure you capitalize. I think that matters. I'm not actually sure though. So we're going to say Q is equal to, and then inside quotes, we're going to say transparent. But this is the same value for the Q inside window 1. If you remember, this one is also transparent. So what we're going to do in order to make this render afterwards is do transparent plus 1. And don't worry that this is inside a string. Unity is going to handle the arithmetic correctly. So if we go back to Unity, we see that we can see the box inside the window. And that's because it's rendered after the window is rendered. Okay, so you can actually check that the Q is correct by clicking on this material. No, not that one. This is the window material right here. You can see that the render Q is 3000. And then if we go to this material, we can see that the render Q is 3001. And Unity always renders the Q from lowest to highest. So this box is being rendered right after the window. And I'm also going to go ahead and change the color to red just to make it more interesting to look at. All right, there we go. Okay, and before we move forward, I want to clean up our assets a little bit. So I'm going to move box to a folder I created called FBX, and I'm going to move the frame there as well. And then I'm going to put this material inside this materials folder. And then what I'm going to do is create a new folder called window 1. And let's go ahead and put all the stuff dealing with the first window inside that folder. Okay, and now that we're here, I've gone ahead and created a new material, which is blue. But let me show you how to do that. So we want to put something inside this box to differentiate it from the other windows. So it's going to use the exact same code as the red background though. So what I can do is right click inside one, create, and then material. And then what I can do is set this material to blue just to make it different from the background. And then I'm going to right click up here, 3D object, cube, and then let's make it a little bit smaller. Okay, that looks good. And then put it at 0, 1, 0. And then what I want to do is apply this material to the cube. Yeah, but I can't do that because there's a bunch of stuff in the way that we can't see. So let's grab the cube, move it outside, and then put this material on the cube. And then it disappears, which is what should happen because it's outside of the stencil buffer. So when we move it back in, you can see in real time what happens as it moves inside the stencil buffer with the value 1. So here's 0, and here's 1. So let's put it back at 0. And that should be it for window 1. Okay, so if we go back to our code, we can see that it's a little bit messed up because we moved stuff around in the folders. So we can go ahead, get rid of these, and then go back to Unity. And let's go ahead and reopen both of them. So here's inside 1. And here is window 1. And what we're going to do is go back into our main folder. And then we're going to go ahead and create an unlit shader, which is going to be window 2. Okay, so if we double click to open this up, we can see it's just a fresh shader. And we're going to have basically everything that we had from window 1. So what I'm going to do is something you should never do, which is copy and paste huge chunks of code. So I'm going to grab up here, go all the way down, Control C, go to window 2, and then replace everything from here down, Control V. So all of our transparency stuff is still here, so that's perfect. But don't forget, ref is going to be 2. And the reason it's 2 now is because if it was 1, then we would see exactly the same scene from window 1. So what we're going to do is create objects that are going to check the stencil buffer for the value 2. So let's Control S to save, and back to our scene. And now just to make things a bit easier, what I'm going to do is do that exact same thing, but for the other 3 windows. So let's go ahead, create unlit shader, window 3, and create unlit shader, and let's call it window 4. And I'm going to open up both of these. Here we go, and then I still have window 1 saved to my clipboard, so let's go here and replace everything down here in window 3 with window 1. And then you can probably guess we're going to change ref to 3 instead of 1. Control S. Do the same thing for window 4. Control V, go up here, change ref from 1 to 4. And now back in our scene, what we can do is right click, create material. This is going to be for window 2. So let's just say window 2 is right here, this red one. So if we apply the material and it turns invisible. And because this value in the stencil buffer is different, we don't see the scene from window 1. Okay, and then to make things nice, what I'm going to do is create another folder. Here we go, and this one's going to be called window 2. Make another one, window 3, and another one for window 4. Okay, so window 2 is done. So let's go ahead and put that in here. And now we need to do the same thing for window 3. Right click, create material. There we go, apply to window 3. And then let's go ahead and move these into window 3. And window 4, right click, create material, and apply. So yeah, this is a bit repetitive because we have 4 windows, but it's gonna look really cool at the end. Okay, so now what we need to do is do basically the same thing we just did, but for the stuff inside. So let's create a shader. This is gonna be a surface shader because we want that stuff to interact with light. This is gonna be inside too. So let's go ahead, create a material. And let's go ahead and copy paste and get rid of all of these. So here's inside 1. I'm going to do the exact same thing I did before, but we don't really need anything down there. So I'm just going to grab these. And we can go ahead and replace this. So Control V. And then again, this needs to be ref 2. Control S to save. And let's go ahead and do that for the other 2 shaders. So standard surface, inside 3. So replace this, Control V, ref 3, Control S, back to Unity, create another one. Inside 4. There's probably an easier way to duplicate, and that's going to make me look like an idiot, but this is the easiest way I found. So let's go ahead and Control V and ref 4, Control S, and we are finally done with the code. There should be no more coding, I think. So what we can do now is put this shader, this is inside 2, we're going to put it on this thing right here. And then now that was what, box 1? So it's invisible, so you can still find it up here even if it's invisible. And we're going to put it at 0, 1, 0. So now it's in here and we can see it. And let's make it something interesting. How about green? There we go. Maybe, yeah, green is fine. Okay, and then let's go ahead and make another centerpiece for that window. It can be a sphere. And again, let's make it a bit smaller. And put it at 0, 1, 0. Here we go. And then we're going to need to create another material because otherwise it would just be green and it would blend in too much. I don't know. Maybe you want that. That's fine. But we're going to create another material from this shader. This one is going to be, let's do purple. I feel like that'd be a nice contrast. So where's our sphere? Here it is. And grab the purple one, put it on top of the sphere, drag it back in, and there we go. Okay, so now window 2 is done. Let's go ahead and grab these, put them in window 2 folder. There we go. And okay, inside 3, we're going to create a material from this shader, just like before. And from here on out, it's basically just going to be copies of what we did. So let's put him right there. And then that was box 2. 0, 1, 0. And let's swing our camera around. Sorry, I hope you don't get motion sickness. And okay, we need a new color. Let's try, I guess we could do blue. And that looks good. So for this one, maybe we could put a capsule inside. So we'll put him, whoop, not 10. Let's do 1 and 0. And we're actually gonna have to slide him out anyway, so let's change the scale again. I think 0.8 works pretty well. It's pretty tall actually, maybe 0.6, and he's kind of fat now, so let's just do 0.6. Okay, there we go, and slide him out and create another material from inside 3 so it has the same stencil buffer code. There we go, and apply it. to him and capsule. There we go. So X is 0. And we take a look at that material we just made. Maybe we can make him red just to keep that contrast going. Okay, and that's it. So this will go in window 3 like that, just to keep things organized. And then let's go ahead and create a material from our last file and apply it to box 3, and then put him where he needs to go. Here we are. And then I kind of want this one to be orange. I don't know why, but he's going to be orange. I feel like orange blue would be a nice contrast, even though we already have a blue one. But let's make, I guess we only have a cylinder left really, so let's him same size as the capsule, and create another material. Where is material? There it is. And apply. And put it back in there. 0, 1, 0. And then press W, E to get rotation, just to make it look different. And then let's see, what's a good color? I feel like bluish. Maybe that kind of blue. Okay, and into window 4. And with that, we have finished our work on the Antichamber box. So if you stuck around for the whole thing, I hope you're satisfied with the result. And the rest of this is just going to be me putting the components into an empty game object so that we can rotate the box around without having to move the camera. So yeah, feel free to leave a comment. Could I do anything better? Were there things that didn't make any sense? Are there any game concepts or ideas that you want me to explore in another video? Please feel free to leave a comment suggesting those, and I hope to see you in my next video.